Hello, grade 7 students. In this presentation, we are going to talk about our new chapter, respiration. So the first question and the big question here is, can we live on Mars? Yes. Why? And if no, why? First of all, let's start with respiration. Respiration, it contains two important respiratory gases. They are oxygen gas and carbon dioxide. They are O2 and CO2. To start first, let's have a look about the respiratory system, about the organs of the respiratory system. Here we have the nose and the mouth, the pharynx, larynx, the trachea, the lungs, bronchus, the bronchioles, and you have the alveoli. So, what is the most important organ inside the respiratory system of humans? Sure, it's the lung. So, the lung is the most important part of our respiratory system. So, let's have a look about the pathway of air along the respiratory system. First, we have the nose, we have the pharynx, the larynx, the trachea, the bronchus, and the bronchioles. And finally, we have the alveoli. So breathing is the actual mechanical intake of air. It consists of two main phases, inhalation and exhalation. Inhalation is the process of taking in air. When we breathe, we take in air inside our body. This is called inhalation. Whenever we release the air outside the body, this is called exhalation. Breathing in and breathing out, if you have here the chest expand during breathing in, and you have expansion of the chest. Here, the chest contract when you breathe out. So breathing in causes the thoracic cage to raise. So here, this is the table showing the different respiratory movements during both inhalation and exhalation. During inhalation, the position of the thoracic cage is raised. The thoracic cage is raised during inhalation, and during exhalation, it's lowered, it decreases. So state of the lungs, we have inhalation. So the air is going to enter inside our lung. So the lungs are going to be inflated. While exhalation, the lungs will be deflated. The air is going to be released outside the lungs. Volume of the thoracic cage. Inhalation, the volume of the thoracic cage increases, while during exhalation, the volume of the thoracic cage decreases or diminishes. Pathway of air. Air during inhalation is from outside to inside. So we get air from the environment around us and enter the air inside our body. Why? The opposite is true for exhalation. Exhalation, the air is released from inside our body to the external medium, to the environment around us. So here we have opposite between inhalation and exhalation. Respiratory movement of the grasshopper. The grasshopper has different respiratory movement. The abdomen is raised, the abdomen is lowered. During the inhalation, the abdomen is lowered, while during exhalation, the abdomen is raised. As you see here, the difference is raised here, it's lowered. So this is the respiration. Grasshopper. Respiratory organ in all insect, it's the trachea. The trachea is the respiratory organ in insects where the air is going to enter through the spiracle. Inside the insect, we have the trachea. It's going to be distributed to the tracheal. Till now, we have two respiratory organs. Both of them, they live on land. Lungs, they have mammal. Trachea, they have insects. So both of them, they live on land. Now, let's move to the aquatic life. Now, turn of our fish. Fish has different organs. These are operculum and the mouth. So what happens with the operculum and the mouth during the respiration process? The mouth is open. Mouth is open, it allows the water to enter. And the operculum here is closed. This is the inhalation process. Why? When the mouth is closed and the operculum is open, this is called exhalation. So the fish respire, mouth is open, perculum is closed, it's called inhalation. Mouth is closed, perculum is open, it's called exhalation. So let's move now to respiratory organ of the fish. Is it the operculum? No, it's not the mouth, too. It's the gills. The gills are the respiratory organ of the fish. So we have gills, they are seen in the skin. We have gills on the skin of the fish. Here, the diagram that shows the explanation about respiration. Air gets in during inhalation for animals living on land, like the insects and mammals, and air gets out during the process of exhalation. Animal living in water, during inhalation, water gets in, and during exhalation, water gets out. So as you know, inhalation, air in, water in, inhalation, air out, water out, exhalation, exit outside the body. So this is the respiration process. When animals or plants respire, what happens to the air or the water around? What do they observe from them, or what do they release? So here you have an important note that you have to pay attention to this note very well. Dry water, it turns out to be turbid in the presence of carbon dioxide, CO2. So let's start here with what is respiratory gas exchange? Respiratory gas exchange is the passage of respiratory gases between air or water and the respiratory organs. Which gases are the respiratory organ? In this experiment, the aim is to study the respiratory gas exchange in fish. Here we have the respiratory gas exchange. This table is showing the variation of the quantity of oxygen, carbon dioxide, and nitrogen gases in water in milliliter as a function of time in minutes. So the quantity of oxygen gas in water, it was 7 milliliter at time zero. It decreases to 5.6 after 6 minutes, meaning that the amount of oxygen is decreasing. So the oxygen gas is the gas which is consumed, while carbon dioxide was 3 milliliter at the beginning of the experiment. It increases to 4.1, meaning that the amount of carbon dioxide is increasing. So carbon dioxide is the gas which is released. Quantity of nitrogen gas in milliliter. We have 19 milliliter, which is a constant, meaning that neither absorbed nor released. Nitrogen gas not absorbed, not released. So let's see, what do we call the nitrogen gas? So transform the table into a graph. We have to interpret and what can we deduce. First, this graph is showing a decreasing, a line that is decreasing. So this amount is decreasing towards the oxygen. And we have the carbon dioxide. Carbon dioxide, which is green in color, it's increasing. And the nitrogen gas remains constant at 19 milliliter. So at time zero, the quantities of oxygen, carbon dioxide, and nitrogen gases in water, they were 73 and 19 milliliter respectively. So as time passes, the quantity of oxygen decreases to reach the minimum value at 5.6, where the time is equal to 6 minutes. You have to pay attention. You have to mention the values and their units. Milliliter for the volume, minutes for the time. So here, we keep that the fish is consuming oxygen. So we can deduce that oxygen is a respiratory gas. As time passes, the quantity of carbon dioxide increases to reach the maximum, which is 4.1 at times 6 minutes. So this indicates that the fish is releasing carbon dioxide. Carbon dioxide is increasing in value. So this indicates that carbon dioxide is a respiratory gas since its value is increasing. As time passes from 0 to 6 minutes, the quantity of nitrogen remains constant at 19 milliliter. This indicates that the fish neither consumes nor absorbs nitrogen gas. The nitrogen is not a respiratory gas since its value remains constant. So you have to pay attention to this. So what can we deduce here? We can deduce that the fish respires. It inhales, meaning that it consumes oxygen and exhales carbon dioxide. Respiration very immediate. What is the respiratory organ of mammals living on land? Sure, the lungs. These lungs showing high number of blood vessels. Why do we have high number of vessels? Why do we have what happens when it reaches lungs? These questions, I'm going to answer that in the coming slides. So what is the element responsible for the transportation of oxygen and carbon dioxide in our body? Sure, it's the blood. That's why we have high number of blood vessels in the lungs. We call it highly vascularized, or you can say rich in blood vessels. Blood reaching the lungs will be poor in oxygen and rich in carbon dioxide, but the air in the lungs is rich in oxygen and poor in carbon dioxide. Pay attention here to the difference. The blood reaching the lungs is very poor in oxygen, has low amount of oxygen, and very rich in carbon dioxide, high amount of carbon dioxide. But the air in the lungs is rich in oxygen and poor in carbon dioxide. So what happens to the blood when it enters the lungs? Let's see. This table is showing the variation of the quantity of oxygen and carbon dioxide for on each 100 milliliter of blood entering and blood leaving the lungs. In the blood entering and the blood leaving, we have oxygen. Also in the blood entering and blood leaving, we have carbon dioxide. So you have to compare here. Let's compare between the quantity of oxygen in the blood entering and the blood leaving. In the blood entering, the quantity of oxygen was 15 milliliter, which is less than the quantity of oxygen in the blood leaving the lungs, which is 20 milliliter for each 100 milliliter of blood. So this is comparison. Moving for carbon dioxide, the quantity of carbon dioxide, the blood entering the lungs is 53 milliliter for each 100 milliliter of blood, which is less than the quantity of carbon dioxide, or less than, you can say that. Instead of saying the quantity again, quantity of carbon dioxide, you can say less than that and the blood leaving the lung, which is 49. We have to compare the oxygen with the oxygen, blood entering, blood leaving, and carbon dioxide with carbon dioxide, the blood entering, and the blood leaving. We can compare oxygen with carbon dioxide for sure. So this shows that carbon dioxide and oxygen, they are transported away and to the lungs, where the blood entering is poor in oxygen and the blood leaving is rich in oxygen. It's a figure showing the blood capillaries, showing the oxygen gas entering, carbon dioxide leaving. What is the respiratory organ of some animals living on land? It's the lungs for sure, like humans, rabbits, frogs on land. Pay attention to the frogs. So when the respiratory organ is the lung, animals they have special type of respiration. It's called pulmonary respiration. But the other animals respire on land, but lack lungs, they are insects. Is the main respiratory organ, it's the trachea. So what do we call this type of respiration? It's called tracheal respiration. Oxygen gas diffuses. What's the meaning of diffuses? Diffuses meaning that it moves from a medium of high concentration to a medium low concentration in the substance. So oxygen gas diffuses from a medium highly rich in oxygen, which is the trachea, directly to the organs that are poor. So diffusion is the movement of a substance from a medium containing high concentration of the substance to a medium containing low concentration of the substance. So carbon dioxide diffuses from organs that are rich in carbon dioxide to the trachea, which is poor in carbon dioxide. In earthworms, the skin is the respiratory organ. What do we call this type of respiration? It's called cutaneous respiration. So as a conclusion, here we have before we move to the fish, cutaneous respiration for earthworm that respire through the skin, pulmonary respiration for respiration using the lungs, we have tracheal respiration for respiration using the trachea. So what is the respiratory organ of fish? It's called the gills. We have four gills on each side. So what happens? Water enters the mouth. Water entering is rich in oxygen and poor in carbon dioxide. Water rich in the gills where blood vessels are poor in oxygen and rich in carbon dioxide. Oxygen diffuses from water rich in oxygen to the blood gills is poor in oxygen, while carbon dioxide diffuses from the blood that's rich in carbon dioxide to the water which is poor in carbon dioxide. As such, water will leave the percolate, pure on oxygen, and it's going to be rich in carbon dioxide. And then the water frogs they respire through their skin. So their skin becomes the main respiratory organ. So underwater frogs they have other type of respiration on the land. They have underwater cutaneous respiration. So as a conclusion, frogs as an amphibian, an animal that lives on both land and water. On land it has pulmonary respiration, and water it has cutaneous respiration. Thank you guys for watching this video and see you very soon. Bye bye.